Okay, so we'll continue with math models. Last time we basically just presented to you some simple problems to solve. We'll do 2 problems hopefully by the end of the class today. Okay, so this part is just about the complete post condition. You can review it, about how to use the old keyword and how to use deep twin. Okay, review that please to get to the math model part. Okay, again, so this is what we are trying to solve as first example for math model. Okay, let me remind you very quickly. We basically want to implement the same data structure called stack, last in, first out, what you learned back in 2030 or 2011. And then this is a difference. Strategy number 1, we are using an array, and the end of the array is the top of the stack. Strategy number 2, we're using a linked list, and the first item, the head of the list, is the top of the stack. And then for the strategy number 3, similar to 1, we are using a linked list, but now the last element of the stack, the last element of the list is the top of the stack. Okay, 3 strategies. Okay, make it simple to illustrate the point. So now, let's try to do that. So now, rather than focusing too much on the code, we want to focus a little bit more for this lecture on the contracts. Okay? I asked you guys this question last time. Let's ask again. Can you imagine that we're going to have very identical contracts, let's say post condition, for push and pop, for all the 3 strategies, or we're going to get very different contracts? Either identical or not. How about that? Let me put it that way. Would that be identical contracts? I heard yes. That's okay. Just follow your intuition. I heard yes. Anybody who think that will be no? Okay. I guess most of you say yes, right? For those who responded. Okay. Let's see. Okay. Let's look at strategy number 1. Remember, for strategy number 1, we're using an array. That's why you see implementation here is an array. The last elements in the array will be the top of the stack. We got to make over here to make empty stack, and also we got push, okay, which is force to the end. So now let's practice quickly. Okay, it might be nice to review a little bit how you can write complete post condition. So now, can you tell me for the push, which spot or spots we want to change on the stack or the array? Just the last one. Is that the only place? Okay, so now this one should be easy to write. Does Jordan want to suggest something? However, okay, this one changed simply tells me which one will be changed. Yeah, so that you don't need a loop in some way. You don't need a cross, okay? Something like this. You will say imp, at the end of the array, that should be G. That one should be easy. The next one is going to be similar to what you just mentioned, okay? We want to say others unchanged, right? We practiced that, back in the class and also for your lab. How do we specify that? That's correct. Imp position count is talking about the last element in the array. You can look at the last one, yes, because last one is the top of the stack. Correct. Okay, for unchanged, let me help you a little bit. Okay, let's see how we can write it quickly before I show it to you. Okay, so here we talk about, we talk about push. Okay, let's say for the push, let's say for strategy number 1, we're going to put to the end of the array. Let's say if this is a current array, let's say it says old, eventually it will become old. Let's say this is old array, and then let's say we only got, we only got 4 things over here. Let's say the size is 4, just to make it easy. If I got A here, B here, C here, and D here. So I know that this is the top of the stack currently, right? The last elements, okay? If I say push, stack.push, I want to push E, okay? As you should know very well, in that case, what we will do is, we can grow the array if you wish, but let me just put it. But basically, A will be here, B will be here, C will be here, D will be here, and E will be here at the end, right? So that's the current one. Okay, so now the one we just talked about, we say the last element in the array should be G. You can think about the G over here is E, right? So the last element of the array, so this will be the new top. So that one has been covered. How do we specify the rest? How do we do that? We want to say somehow the ABCD in the old somehow correspond to the ABCD in the current. Mm-hmm. Yeah. Okay. So yeah, I think you're pretty much getting there. Basically, you need a combination of old, deep twin, and also a cross. Somehow in that kind of combination. The tricky thing is, I want to point out to you, in the current one, you got 1, 2, 3, and 4. So these are the indices, 1, 2, 3, 4, right? Somehow, they correspond to simply 1, 2, 3, 4. That's an easy case. So that means when you go across, I will show you the code. Number 1, index 1 should correspond to index 1. Index 2 should correspond to index 2. 3 correspond to 3, and 4 correspond to 4. That's an easy case. Okay? Very easy. Okay? So exactly like what Tammy said, that's what you'll get. You go across from 1 until count minus 1, and then compare them one by one. Okay? They're just in the corresponding position. That's how you write the complete postcondition. Okay? Any questions? There's a quick review. We can get a tricky one, maybe for the second strategy. We'll see that. Okay, so now for the pop, it's going to be something very similar. Okay, I just want to help you for those of you who didn't quite know how to fix that. Okay, changed would be we just want to make sure the count has been decremented by 1. Okay, so now let's talk about how we can do pop. Okay, let's say for the pop feature command, and we talk about strategy number 1. This one is a little bit more interesting, a little bit more. Let's say we got old stack. Let's say we still got ABCD. ABCD. And this is the top. Okay? And now, if we try to do pop, and what would be the current one? That means we're removing the last, right? So that means what you will get is you'll simply get A, B, C. Okay? That's what you will get. Actually, you know what? It's not that interesting still. Because you will see that index 1, 2, and 3, index 1, 2, and 3, they will still correspond to each other. Okay? But you just got to know how to write it, depending on the strategy. Okay, so if you look at the code, it's going to be very similar to what we had before. You can see they simply either item correspond to each other. Okay? Any question about the first strategy? Okay? Let's talk about the second strategy. The third one will be very similar to the first. Okay? The second strategy was we're going to treat the beginning of the linked list as the top rather than the end. Okay? Let's see that. Okay, we got a linked list over here. You can see the implementation is now different. And also the strategy is different because the first item will be the top. And then for the make, just make an empty list. And also for the push, you can call the put front. And also changed would be very similar. You can say imp.first rather than the last item, right? So now, how do we specify this? Question number 1. Is the contract we're going to put here identical to what we did for the strategy number 1? I heard no. But how different should they be? Do we need a cross loop? We do need a cross loop. But do we need old keyword and deep twin? Yeah. But what will be the difference then? Yeah, you want to just briefly describe and then we can look at that. Yeah. From the first index to the second to last index. That's the first strategy, yes. But with this one, since it has moved you to the top of the stack, check from the second index to the last, right? So now, because strategy is different, so now if you want to talk about the remaining part of the stack, you want to go from index 2 until the last index. Okay? Let me illustrate it to you, and then we'll look at the code. Okay? What I will do is, let's still talk about push and pop. Okay? Let's say we talk about push, so we'll talk about strategy number 2. Okay, and then let's say this. let's say we have a linked list. I'll make it 3 elements only. A, B, and C. Okay, that's index 1, index 2, index 3. And let's say this is the old stack implementation. And then we'll simply say push, let's say D into it. So now, do we add to the front or add to the end? The front, right? Oh, before I do that, remember the top of the stack will just be the front. So now to update the front, that means we update the top at the same time. Okay? So what we will do is we're going to have, let's say this. We're going to have D over here, and then it's going to point to the rest, the same. A, and then B, and then C. Right? Notice that the indices is going to be 1, 2, 3, and 4. Okay, that's the current. And don't forget, this is not a new top. Any question about this? Because the front of the list is the top of the stack. Correct. For strategy number 2, we assume the front of the list, the first element of the list is the top. Mm-hmm. The first one is the top. Mm-hmm. Correct. Okay, so now how do we write the loop? As Chelsea pointed out, if I want to talk about the remaining part of the stack, it's going to be basically this part over here, right? This part corresponds to this part in the old stack. If you look at the indices over here, you can see 2 correspond to 1, 3 correspond to 2, and 4 correspond to 3. You can see that? Okay, so if you simply repeat the contract you wrote for the first strategy, you're going to run into trouble. Okay? You might compile, but you run into runtime trouble, violation. How do we write this? We can write this together. Okay, just the first one, we can do it together. What should I across over? Anyone? I say across. Across, let's say, for example, let's say imp. Let's say this is the imp. Okay. Across what? From where to where? From 2? Okay, I heard 2. 2 until, okay, count? Yeah, count will be okay, because remember, there should be invariant saying count should be the same as imp.count. Okay. Across this is, let's say I. Okay, and then should I use for all or exists? All, right? Okay, don't forget. Very good. Okay, so now what should we put here? Something like that. Okay, let's say this. Basically, you want to say imp at position something over here should be the same as old imp dot deep twin, right? At position something. So now the point is, in the previous strategy, they will be the same. What about the current strategy? Should I put I and I here? Where should I put I? Okay, first one here, right? I could be 2, in which case the corresponding element should be I minus 1, which is 1. Okay? Okay, it's a subtlety here you want to watch out. Okay? Any question about this? That's correct. Yes.
We have also done where we could have accounted for the first variable changing and accounted, and like for example, we could have done 2 conditional statements. So if it's the first one, it implies that it's not in the old one. But if it's not the old, if it's not the first one, then it implies that it should be in the.
Yeah, maybe that's a bit too overcomplicating. I would say this might be the simplest one to write. Yeah, of course, if you got other solutions, show it to me. I can discuss that next time. Okay, guys, any question about this? Okay, I assume you're okay. But I would say in case you have to really write such contract where the implementation may not correspond, where the old and new version may not correspond to each other so straightforwardly, drawing a diagram like how I did would be the best way to go. Okay, that's my point. Okay, so now if you go back to the original code, what you will see is exactly that. Okay, we got this. And then for the pop, I'll leave that as an exercise for you. Something similar. But now in the pop, you have to somehow use +1 as opposed to -1. Okay, that would be your exercise. Okay, draw some diagram to convince yourself. We have already seen somehow we are repeating very similar pattern for the across. Agree over here? You can see the first version. Okay, in the third version there, let me make my point a little bit later. The third version, I'm not going to bother you, but basically the third version is going to be a linked list. Okay. However, different from the strategy number 2. Now the end of the list is going to be the top. So the contract will be somehow similar to strategy number 1, but not for strategy number 2, right? So somehow the 3 versions are not exactly the same, but they're similar. So you got repetitions. That's the point. Okay, for that one there, I'm going to just leave that to you. Okay, very similar. So now let's compare them very quickly. So now, so these are all the 3 versions over here. Okay, this is version 1. Okay, you can see that basically the structure for the loop is very similar. I here, and then strategy number 2, you got I here, you got I -1 here, different, right? In strategy number 3, again, you got I here, you got I here, right? So it's not exactly the same. Moreover to it, you can see over here in strategy number 1, we're using imp at position count. We're using the indexing notation to get to the last part of the array. On the other hand, for strategy number 2, we're using the first feature from linked list. And first feature is not a feature for array. It's for linked list, which means this first is this contract here, this guy here, is very much depending upon the strategy you're using, especially we're using a linked list. Okay. Similarly, you can see version number 3 here. We're using, again, linked list, but now we're going to say imp.last. Right? You can see we're basically talking about something very similar, just 3 different versions. Okay. So we got lots of repetitions. So now a question for you. Is this a good design? Well, apparently not, right? If you got many repetitions, which principle are you violating? Is it a single pattern principle? Single choice principle, yes. Okay, it's not single pattern principle. There's no such principle. Okay, single choice. So now, can anybody tell me if you think we are violating the single choice principle? How so? How? Or if you tell me the single choice principle, you got to explain to me why, right? Jordan first. Yeah, I agree. So you got duplicates, but you want to go one step further. When you say, okay, if you say we are violating single choice principle because we got duplicates in the contract, that's only partially correct. You want to go one step further.
It's because if you were to change the implementation from an array to a linked list, then we have to change the code in multiple places.
Very good. That's exactly correct. Let me just repeat. So it's violating single choice principle because of 2 things. Okay. So single choice principle is violated for 2 reasons. Number 1, you got duplicates. And the interesting thing about this example is we got duplicates not in the implementation, but we got duplicates in the contracts. Okay, that's still part of your code. And number 2 is what's missing from Jordan's answer. So you want to go one step further. You want to talk about when you actually want to change, how many places do you have to change? That's the main issue here. Okay, so let's say change on implementation or change on data structure. Change on implementation may involve multiple places, multiple changes on contracts. Okay, let me just illustrate one example to you. Okay, let me take strategy number 1 here. Okay, let me talk about this particular strategy. Okay, let's say I want to make changes as follows. I want to make sure I use a linked list where the first element is the top. I kind of consider this a simple change, right? Even though you talk about two things, but it's a change. I want to change the data structure from array to linked list. And at the same time, I want to make sure now the first of the list is the top. So now, do I need to change many places over here? Quite many, right? Well, quite a few, at least more than one. First of all, I want to make sure, so this guy here is not going to compile anymore. Well, it will compile, but it's not correct. So you can definitely change this to, for example, implementation at position 1. That might work, the first spot of the array. And then also, these two indices have to be changed as well, as we talk about, right? So multiple places. Okay. It would be very nice if we can somehow write our contracts in a way so that whenever we change our implementation, we don't have to change the contracts. That would be the ideal solution. So how do we do that? Math models. Okay? Math model is one way to achieve it. Okay? All right, let's go back to the slides quickly, okay, and then we'll talk about how you can use math model, and then we'll revisit this example again. Okay, so now, okay, exactly what I said. Okay, we talk about information hiding and also single choice principle, right? Okay, so whenever you change the implementation strategy, you're going to change multiple places. Okay, that one has been covered. Okay, so now let's see how we can use the math models, and I'll explain to you how it works at the runtime and also conceptually. The idea is you don't want to really think about a stack just as an array or as a linked list. Think about it more abstractly, maybe as a sequence or just more mathematically. Okay, let's see how we can do it. Okay, so we're going to use math models. Okay, let me show you right away the math models. Okay, let's see this. Okay, so the math models library, you have been importing it since lab 0, but we never get a chance to use it. You will get a chance to have a simple lab towards the end of the semester. But let's see this. Basically, in the math models, if you look into the library from iPhone Studio, there are many things that you learned back in 1090. You learned about function, you learned about sequence, you learned about relation, right? Also, you learned about graph. Also, we got a graph over there. You can also look at that for your personal interest. There are many, many mathematical concepts over there you can use to write contracts. Okay, so now let me just talk about there are two ways you can use the math models. Okay, the most important thing is to look at the following. Let's see this. We have, let's say we have a class where the class is here. We just call that level stack. And then we have, let's say currently, the implementation is a linked list, but it might be changed to something else later. It might be. So now what we will do instead is to define some auxiliary query over here. Okay? The query takes no arguments. You can see just model. Just call that model. And then the return type is simply just a sequence. And the sequence is simply just a type from math models. Okay? So this is from math models. Okay, it's from there. And then the way we implement this particular query goes like this. Let's just go over that, and then I'll explain to you what it means in the big picture. What we will do is, first of all, result is of type sequence. We simply create an empty sequence to begin with to return. Okay? And then we simply go across the implementation. At the moment, it is a linked list. Go over the linked list, and then we simply keep appending. So the append simply means insert to the end, like a force in the array. Okay? Keep appending to the end of the sequence that we are returning, and then whatever it is returned, that's what we get. Okay? And then let's see some example over here. Okay? I'll pause a little bit and go over some example with you. So now let's think about this particular example here. Okay, let's talk about this stack at the top. So let's say somehow we got this stack here. We got Alan, Mark, and Tom. Apparently the current top is Tom. Okay? Now, strategy number 1, this is the top. Strategy number 2, the front is the top. Strategy number, this should be 3. Sorry, that's not 2. Strategy number 3, this should be the top. Okay? If you don't mind, to avoid any confusion, can I fix it quickly? Okay, that's 3. Okay, so now let's have a look. what I want you to convince yourself before I try to trace for you, can you tell me something? Let's say I simply change from strategy number 1 to 2 or from 2 to 3. Am I going to get the same return value for model? Well, it depends on how you define the model, right? It depends. Okay? Let's just say for strategy number 2. I want to go back to here. What we do is, over here, if you look at this loop here, okay, we'll simply keep appending. That's what we will do. Okay, that's for strategy number, let me just see, sorry. Let me just make it clear. So this should be strategy number 3. Okay, just make it clear here. Yes? So the append actually comes from the sequence. So okay, you know what? Let me show it to you. You're going to get basically 3 versions of the model. Let me show you here. Okay. So now let's talk about strategy number 1. You got a model here, and then it's going to be a sequence of generic type. And then you're going to say do, and then end. Let's assume that we already got result being created as empty. Let's assume. Okay. What we will do is you're going to say across the imp. In this case, the implementation is referring to this particular array. Across imp as, let's say is, let's say g, and then loop, end. And then you simply say result dot append. And then we'll say g. Keep appending. Okay? So now let's talk about the blue one first. So this is the version I claim to work for version number 1, strategy number 1. What would the sequence look like? How many iterations do we have? 3, right? 1, 2, 3. After the first, initially we start with a model that's empty, right? Before the first iteration. And now we try to append the current element we're looking at to the end of the sequence. The first one will be just Alan. So after that, we're going to get Alan. Agree? After the second iteration, we're going to append this guy here to the end. After the third iteration, we're going to append Tom to the end. So this is the model that we get eventually. Okay? Which is just a sequence. You can think about a sequence, it's a little bit like an array, but it's more just a mathematical sequence. You can think about sequence like a function from integer indices mapped to the elements. Yeah. So that's a sequence. But you will see more queries and commands as you go. Any question about this? So now question. If I simply change from strategy number 1 to strategy number 2, let's say. Now, let's say we want to make a change. I want to change from this into this. And now, do I need to redefine the model so that I can get the same sequence? Do I need to? Well, if I simply use the same, let's see what's going to happen. To save time, I'm just going to copy and paste. Okay, I'll put it here. Okay, so now let's have a look at this. I should change the color so you can see that. Let's say for the second strategy, we're going to use pink. Okay, color and then pink. Okay, let's have a look. So now, if I simply keep this particular code, which means I keep appending, am I going to get the same model? Let's see. Okay, let's see. Number 1, you have to convince yourself this guy here is corresponding to this particular stack because Alan over here, Tom over here is the top. Okay, number 1. And also this linked list over here is also corresponding to this particular stack because you can see over here, am I actually, wow, it's pretty bad. Bad annotation over here. Sorry to make you confusing. Okay, what I meant to draw for the list would be Tom should be here, and then Mark should be here, and Alan should be here. Okay, sorry about that. So here, Alan is Alan, Mark, and Tom. I thought too, you actually got the front of the list as the top, right? So this one, Tom is the top. So Tom is the top. The third one, yes, absolutely. Do you think that might be okay? Okay. Okay, let me say it again. Sorry for the confusion. Now, let's see this. For strategy number 1, the end of the array is the top of the stack, which is Tom. Okay? For strategy number 2, the front of the list, which is Tom, is the top of the stack. Strategy number 3, the end of the linked list, which is Tom, is now the top of the stack. Okay, so now we're consistent. Okay, good. So now let's say this. If I simply apply the same definition for model for strategy number 2, let's see what sequence I'm going to get. Well, if I simply try that, initially it's simply just going to be empty, right? After the first iteration, I'm going to append to the end of the sequence. Well, what would I get? Tom, right? And then after second iteration, I will get Mark. After the third one, I will get Alan. So now, are these two the same sequence? They are not. Can you agree? The goal is we want to say, whenever you change strategy, we only want to touch the model. Is it possible to only modify the model in a single place so that everything else that depends on the model can stay the same? That's basically the idea. Yeah, you can, yeah. When you say common data structure, sure, that's one way to think about it. When you think about model, it's like the abstraction for this particular data structure. Okay? So now, how can we change that? Just change the model. Well, of course, one way to go, you can say, I want to go from the last index and reverse, go back to the first index and keep appending. That's one way to go. Or there's another very handy feature called prepend. Okay, just keep inserting to the front. So now in this second version over here, what I would do is I'm going to say now, rather than append, I'm going to say prepend. So prepend simply means keep insert to the front of the list rather than the end of the list. Okay, the sequence. So now when you go from strategy number 1 to strategy number 2, the only place you have to change, I claim, is to say change from append to prepend. Okay, let's do that quickly. Again, let's see this. Starting the sequence being empty, the first iteration we're going to prepend Tom to the sequence. So after that, we'll get Tom. And the second iteration, we're going to prepend Mark. So that means Mark is going to be prepended this way, right? And this will be Mark. After the third iteration, you're going to prepend Alan, and then Alan will be added to here. And now, would you agree? The two models are really the same. So the idea is every time you want to change your strategy of your implementation or data structure, you only change the way you define the model. That's the single place you change. So because model from the external user's point of view is always the same sequence, that means your contract can just be written in terms of the model. So you don't have to change your contracts. That's the idea. Guys, are we okay? Yeah, sorry about the initial confusion. I'll fix that. Okay. Yes? No, model, the idea is the external user know nothing about your strategy. So the array, the linked list, or any hash table, for example, they should be private. Model should be public. Right? So when a client reads your contract, it should not be in terms of a linked list or array. It should be in terms of mathematical sequence or mathematical relation. Okay. Okay. I want to show you one more thing. Okay. So for strategy number 3, I'm going to leave that to you. Okay. It's going to be the same sequence. Okay. Let me just go back here. I want to show you one very important thing here. As I said over here, this is something called abstraction function. Okay, abstraction function. We are trying to create an abstraction for the array or the linked list being a mathematical sequence. Okay, once you have done that, all you got to do for push, pop, etc., you can write a contract in terms of the model. One example is like this. I want you to read it first. Okay, assuming that we declare the model, okay, and then we simply say for the push, rather than using a cross loop, rather than that, this is what we have to write. Just read it for me now, before I trace it for you. Can anybody try to explain to me how does it look to you? Just explain to me in words. Oh, I know it looks good, yes. Uma, yes. Sure, you're just basically reading out the code, right? Yeah, sure. But what was the intuition behind, basically? Or let me make it clearer to you, okay? Yeah, maybe I wasn't clear in my question. So I want you to, let me be more focused on my question. Can you tell me model here and the model here? What are these? They are sequences. So are we talking about two different sequences? Or are we talking about the same sequence? Are you sure? Yeah, okay. So be careful here, okay? I'll mention that quickly and then we'll trace it. It's really important. You can think about since we got O keyword over here, so that means whatever that goes with the O keyword, which is this guy here. So this guy here, which is model.deepTwin in the pre-states, we're going to make a deep copy and save it somewhere. Okay, that's one separate copy. And then we make whatever push operation you're going to do. And then we call the model again. Every mention to the model over here, okay, so you can think about these two models represent two separate calls to the model query. You can think about in pre-states, we try to call model, which will trigger the execution of this loop for the first time. And then after the push has been done, we call the model again. And then it's going to execute this loop again to see how the state of the object has been changed. Right? 2 times. Okay? Question? Oh, you're okay. You're okay. Yeah. Okay, let's trace this a little bit. Yeah, question.
I'm just kind of confused about how the append is working here syntactically because comparing the sequence of model to...
Oh, yeah. Good, good, good. Oh, good. Sorry, I forgot to mention that part. Did you notice one thing here? You can see this guy here. This is called append. This is appended. Okay? The difference is when you say append, that means you're invoking a mutator or command. It doesn't return anything. When you say appended, that's the interesting bit. So it works a little bit like a string in Java, which is immutable. When you say appended, it doesn't simply just perform update. It doesn't modify the context objects. Instead, it returns a new objects. Okay? So now let me just tell you this. Let's say, for example, let's say if I have a sequence over here, okay, the sequence is pointing to some mathematical sequence, right? A, B, and C. Okay? If I say sequence dot append D, so this is a command, which means I will simply modify the same objects and do D. Okay? On the other hand, if I say sequence dot appended, let's say E, and then let's say sequence 2 is assigned to it. What I'm doing is I'm basically creating conceptually sequence 2 is referring to a new sequence, which is going to be almost the same as before. So I got A, B, and C, except that, okay, let me just make more space for myself. Okay. It's basically the same as before, except that we're going to get E at the end. Correct. Appended, also we call it immutable query. So you will see many instances of this in the math model class. Okay, so appended over here is so-called immutable query. And this one here is just a command. Typically, you will use the command in the context of the model in order to build, the model, using a loop, for example. And then use the immutable query in order to write contracts. Okay, so let me write it down. You will see that in the slides anyway. So in your math models library, you got two kinds of things. One is commands. Also, you got immutable queries. For the commands, you will typically use to implement the model. Implement the model query, like how we see, for example, append. That's just one example. Okay, for the immutable query, you will use to write contracts. In that case, for example, you can see the one for push. Okay, it's a very quick summary. You will see that anyway in the slides later. Yes? So somehow you want to combine the immutable query, deep twin, and old all together. Somehow you want to combine them in a way. But let's trace it together first. Okay. Yes? Appended? Well, actually, don't mix the stack with sequence. Sequence is simply a sequence of things, right? We're just using sequence as the model for stack. Yeah, don't think about sequence as a stack. Yeah. Mm-hmm. Okay, so now let's go back there. Okay, let me trace a little bit further just to make sure you're okay with that. Okay. So now let's have a look. Okay. Let me make sure we are okay. The stack is, okay, again, let me just copy this stack over here and put it here. Okay, apparently I also got a sequence wrong. Okay, if you allow me to fix it. So this guy here should be Tom, Mark, and also Alan. Okay, let me fix it. Okay. Let's say we talk about strategy number 2, where the first element in the list is the top, let's say. Okay. So now we want to see exactly how things will interact with each other. Okay, we want to see that. Okay, and don't forget, this is the contract we are talking about. We're talking about for push. So that means we got model versus old model, also deep twin. In total, we're going to call model twice. One in the pre-states, the other one in the post-states. Okay, 2 times. So now in the pre-states, we know that over here, you can see with the old keyword, we know that we should really say model.deepTwin. So before we execute the push, so what we have to do is to run that loop, right? We're going to keep prepending. That's what we'll do, right? Don't forget, it's keep prepending. Okay, we started with some empty sequence. After the first iteration, we're going to prepend Tom to it. Okay. Okay, let me just move this guy here so we can see that more clearly. And move as a stack. We start with an empty stack. After the first iteration, we're going to prepend Tom, the first elements, right? So Tom will be here. After the second iteration, we'll prepend Mark. After the third iteration, we'll prepend Alan. Okay? And then, apparently, we're going to make a deep twin of that, right? Just imagine that that's already, okay, I can just make a deep twin. That's not a problem. You can think about this is the model here that we just create, and then we're going to make a deep twin. Dot. Deep twin is simply just going to point to a sequence over here. It's not exactly very efficient, but that's okay. It's going to be used just for the contract. Mark and Tom. So this is going to be used when we evaluate the post condition. Okay, and we do that in the pre-states. Okay, any questions so far? That's the first call to the model. Question, yes?
It has been done like with any other thing other than model, right?
Yes, but
Just use an array, right?
You mean just use, no. You're basically saying, can we, ask me that question again, maybe a little bit later. Yeah. Basically, the question was, can we use, let's say, array or linked list instead of sequence? The problem is in the array or in the linked list, you don't have the kind of immutable queries that's supported in the sequence. So it's not that easy for you to write contracts. Yeah. Oh, yeah, just harder. Yeah. Okay, so now let's think about how we can change the stack. When you say s.push, so what will we do? Basically, what you will do is you're going to create Jim, let's say over here. Jim is here. And then we're simply going to insert that to the front of the list. Okay? That'll be the front of the list. And then we're going to modify the top of the stack. The top is not going to be here anymore. The top is now going to be here. Guys, are we okay? That's what's changed on the data structure for strategy number 2. Okay, we're just inserting Jim. So now, when we try to evaluate this particular post condition over here, okay, we already got this value here. This value is exactly this sequence over here. It's exactly over there. Okay? So now, how do we evaluate this? Well, we just call the model again and build a sequence from scratch once more. So now, the thing we want to build is building sequence from this particular linked list with 4 elements, right? So what we'll do is I'm going to write it. Let me use red. Again, to call this model, we're going to run a cross loop again. Starting with empty sequence, what would be the first one to prepend? Jim. Exactly. Okay, we prepend Jim over here. And then the next one, prepend Tom. And then prepend Mark. And prepend Alan. Okay, that's a sequence. You can think about this is now the model. So now we got 2 models to compare. So this is model.deepTwin, that's the old one. And this one here, the yellow one, is the new one. So how do we specify a relation between these 2 models? Well, somehow the way we build the sequence is by saying we treat the front of the sequence. Oh, sorry, we treat the last element of the sequence as the top of the stack, right? So that's why you will see over here, we simply say, appended. What is the context object for the appended? It's going to be this guy over here. So we are saying that if you try to append something to this particular old version of the sequence with G, in this case, Jim is a G, you will get the same sequence as the new one. Okay? Think about the blue one over here. When you try to run this appended, what it will do is it's going to create just another sequence, just another one. So what it will do is you can think about model.deepTwin.appended, and then let's say in this case Jim, right? That one is simply just going to point to basically a strictly longer sequence. You got Alan here, you got Mark over here, you got Tom here, and then appended with Jim. So you got Jim here. So now, once again, if you try to compare this sequence over here and this sequence here, they are the same, right? You can see somehow, I know tracing that exact details is a little bit tedious, but I just want to show you. Don't lose the big picture. What we're doing is, whenever you're trying to make some change to your data structure, let's say push, okay? You basically go from one linked list to another linked list from pre to post states. When you do that, you try to keep 2 versions of the model. And then in the post condition, you simply try to specify a relationship between them, and then try to see if they will be consistent. Okay? And guess what? The same contract can survive between strategy number 1, 2, and 3. It will just be the same, because the model return value will just be the same for all the 3 strategies. Questions?
Quick thing, I guess, I'm not sure if that's true, but I guess it has a disadvantage to the kind of thing that we used to do.
Mm-hmm.
Since now if there is a problem in the signature of the method, we're gonna have problem over there because you're directly using the G, right, from the signature of the method. The input, whatever we get.
Yeah. So.
The problem is the input, then.
What do you mean the problem of the input? I'm not too sure what you meant. You mean, okay, so we mentioned G here simply because the argument here is G, right? So you're saying there will be a problem for the input? What do you mean by that?
If there is a like input, like remember when we do the last thing, like the previous things, we would try if there is a wrong implementation and see if we could catch it in the ensure part.
Mm-hmm.
Now if there is anything wrong in the
Oh, no, don't.
we get it, but
No, don't get me wrong. So I can talk about a little bit more detail next time. So it's not really part of the agenda. So the question was, remember I mentioned briefly before, if you want to test for post-condition violation, the way to do it is by creating a descendant class, which will redefine the feature you want to test with some bad behavior. And then that will trigger the corresponding post-condition. The same strategy can also be used for this one. There's nothing wrong with that. Okay? It's a different issue here. Okay? Okay, let me summarize what we have seen. Okay? The idea is actually, that's it. That's the idea. Okay? All that's left is to mention a few more examples for math models, and then go over some diagram and do one more example. Okay? Any question about this before I try to summarize what we have done? I'll try to summarize again. Yes?
Where do you declare the model? Like every single...
Yeah, you declare your model in your application class. Let's say for now we are trying to build an application for stack. Just do it in the stack class.
No, but I mean, like, do I need a model for each method? Or do I need one model?
Okay, let me summarize so that will make it clear. Okay, let me summarize and you can keep asking me. Okay. Okay, what I'm going to summarize is completely consistent with what I said. Okay, let's say this. Let's say we have our class called stack to begin with. And then over here, we simply say implementation array of G, stack of G. Let me just use the, let me use something simple. Let's say the top of the stack. And then I simply say ensure over here. Okay, let me put this a little bit down. Okay. And then over here, I'll say model, which is going to be a sequence. And don't forget, the implementation itself is exported to none. And then the model here will be just public. Okay? In that case, I'll just declare another feature. Okay, that one just exported to any. And it also got top. And then over here, the only detail I'll give to you here is I'm going to say keep appending to the end of the result sequence of G. Okay, so for example, in strategy number 1, okay, we got Alan, we got Mark, we got Tom. So here, this is Alan, this is Mark, this is Tom, right? That's the imp over here. And then if you keep appending, the model you will get. Keep appending, so you get Alan, append to the end, you got Mark. And then keep appending, you get the same. Okay? So the green one is going to be the model that should never change. It's going to stay stable. Okay? The model, the return value. Okay, now how do we do the ensure part? So now the idea is once you create your model here, you don't really refer to any private feature in your post condition, even though you can, but you don't do it. Any suggestion here, the top? Well, I can say, for example, result. Top is going to return some G, of course. So now I can say result is model, whatever the first element in the sequence is, right? Okay, you can say first, for example. That's actually one of the feature in the model in the sequence. So this is only for strategy number 1. Let's see if we switch to strategy number 2, what's going to happen? Okay. what I would do is think about the kind of changes we're going to make. And remember, this part here is a public part, public. The idea is this part here should make no changes to the user when you make a change internally, okay? So now let's think about this. So now I'm going to change this guy here into a linked list of G. That's the first change. At the same time, I'm going to say the front of the list is the top. So that means the new imp is going to represent the stack a little bit differently. So that means I'm going to get Tom over here, and then point to Mark, and also point to Alan. Okay, you can see the two implementations are quite different, right? The order is different. But now, where else should I change in order to make everything just work? I want the green one to be the same. Exactly. Yeah, you don't change the signature for the model, you change only how you implement the model, which is internal anyway. So what I would do is, I will go to this particular model over here. Rather than keep appending, I'm going to say keep prepending. And now, if I try to invoke the model again, am I going to get a same sequence? I am. Because if you think about the model here, in this case, I'm going to keep prepending. Starting with some empty sequence, I will prepend Tom first. Prepend Mark. Prepend Alan. And you can see over here, the two sequences are exactly the same. Agree? So that means, do I need to change this contract over here? I don't, because the sequence is really the same from the external user's point of view. Even though internally you're modifying your data structure or strategy. But since I have done changes to the model accordingly, I don't have to worry about changing the contracts. Contracts depend on model only. Okay? That's something a little bit different from what you did for Lab 1. In Lab 1, you try to use the array directly in your contracts. But overall, it's not a very perfect design. You actually want to create some abstraction for your application and try to use it in all the contracts. So you're free to change from one strategy to another. Okay. Oh, yes?
So regarding the question that he had over there, so are we having the model as a global feature that we're going to keep changing it if
okay.
new
okay, you are partially correct. The model over here, first of all, it is public, right? Right? It's not exported to any particular class. The model, from the external user point of view, they should appear consistently. So that means always the last elements in the model should representing the top of the stack. Always the case, never changes. Doesn't matter how you change the implementation strategy. So now when you go from strategy number 1 to strategy number 2, in order to maintain that consistency for your model, you only modify how you internally implement the model, right? Okay, questions?
Model.last instead of model.first.
Yes. All right. Let's see, we're just talking about Tom here, right? Yeah, you might be right. Yeah, we talk about last element. Okay. Yes. Questions? Yeah, so typically for the implementation structure like an array linked list, they don't really support immutable queries. Immutable queries are somehow inefficient. But now we're talking about writing contracts, so we can maintain single choice principle. So math model is the way to go. It's not efficient, but it's help better design. Okay. Yeah. No, the math model has nothing to do with the IFO-based library. It's a separate, independent library. Any other questions? Okay, guys, is it clear? Everybody? Okay, we still got 20 minutes, right? That's good. Okay, so let me go over maybe one more diagram with you, okay, and then we are done with the stack example. We can do one more, okay? Okay, so now everything has been covered, okay? Let me just go over one diagram with you. conceptually, this is how you can think about. Okay, think about it in this way. Before we introduce math model, we are basically at this particular level over here. We talk about either array, or if you switch the strategy, we talk about linked list, right? Only the red part. We're going to say either from one version of array to another version of array, pre and post states, or from linked list to linked list, right? What we are proposing right now is to say the external user, we want them to think in terms of mathematical model. For example, sequence. We'll see maybe relation in just a little bit later. And then, in order to do that, you have to define the model as an abstraction function, which means it has to be a query. And you can think about every time before you try to make a change, let's say you want to do like a force to the end of the array. Before you do that, you simply convert the current array into a model sequence. That's version number 1. And then after the change to the array, you got to change array over here and call the model again. You get a second version of the sequence. And then you write your contracts in terms of these two sequences, as opposed to between these two arrays. Okay?
What other way would the model feature be used?
The main purpose would be writing contracts, because we can now satisfy single choice principle. I would say in your project, for example, you may choose to use the math model libraries and use the commands, for example. Or you can even use that to write your contracts in your project. That's fine too. I would say primary purpose for math model would be to write good contracts. That's the primary purpose. Yes. The clients can, what do you mean client can change it? Mm-hmm. Mm-hmm. You don't export model to none. No, you don't. Oh, I see what you mean. I see what you mean. That's a good question. What you're saying is this. You know what? Let me address this concern maybe in the next lecture, so I can prepare some small example. Okay, your question was basically that if the model is exported to any, so that means anyone using your cloud, they can also call model specifically and try to call commands on that and modify that. It's possible, yes. Let me address this in the next lecture. I can prepare something. Mm-hmm. If you export it to none, the problem is you cannot use that in the precondition. Yeah, because in the precondition, you can only use public features, so client can actually see. If you export your model to none, so that means you cannot use it. That's a big compromise. We don't want that. Yeah. Let me try to prepare some example to show you, but there's certain assumption we are making. So hopefully you don't want a client to really use the model in a way that you don't want them to. Right? Yes. You have an ancestor client. Uh-huh. Oh, but still the same. Well, you're basically saying this. It may not help too much. I'll mention that quickly. So you're saying that if I say feature exported to none over here, and then I'll simply say model, let's say, which is going to be a sequence of, let's say, generic type. And then you're suggesting that we're simply just going to say public over here. And then you say get model. And then that one, there's going to return another sequence of G. Sure. In that case, well, you know what? In that case, why don't you just make a deep twin in the original model? Yeah. Let me try to summarize you two's question. Maybe I'll try to present maybe next time, so that'll be better. Okay. Okay. I'll hold the question here, and then I will present that, some summary next time. Okay. I'll get there. Okay, so now let me go back to the slides. Any question about this diagram over here? Okay, you're mainly using math model for writing contract. That's the purpose. Okay. And then let me see if there's any more slides, and then we can do some example. Okay, more example. Okay, so everything has been covered. You can look at the diagram, for other strategy. So now the idea is the green part should really be the same across strategies. Okay? From the user's point of view, it's always the same model. Okay? Because the abstraction function will be implemented differently. Okay? Okay, so now let's go a little bit further here. So we are really achieving information hiding because we don't have to expose whether we're using using array or linked list or hash table to the user. We're just using mathematical sequence to write the contracts. Okay? Yes?
So, for example, going back to the interval pattern.
Yes.
Clients can just use the sequence to iterate through whatever our class does.
Yeah, you can think about, it's interesting. In some way, it's a little bit similar to the iterator pattern in the following sense. In the iterator pattern, we say we just want to return one element at a time, regardless of the underlying data structure. Now, it's somehow similar. So here it goes a little bit further to say, now, when the user wants to think about your application, rather than thinking of your application as an array or heap, you want to think about it as a mathematical concept, like a relation or function. Okay, we'll see that, actually. We'll see a second example. Yeah. The sequence is a little bit easy, but just as an introduction. Yeah, we'll see more example. Okay, so everything has been said here. Every time you want to change the implementation, you only change how the abstraction functions are constructed, just the implementation for the model. That's the only thing you change. Okay, so now when you study the slides, this part of the slide is somehow optional. Okay, it's called math review. So that means I'm going to assume if you are comfortable with it, you can skip it. Okay, if you're not so comfortable, review it and come to me for questions, so I don't have to waste everybody's time in the class. So this one here simply review the ideas about sets, relations, and functions, which you kind of learned back in 1090. Okay, yes. So I would say, yeah, review it. Okay, just make sure you got comfortable with it. Okay, we'll just do one or two examples together. Okay, so for that part, I'm going to skip. Okay, that's very basic. Okay, that's why I just included there just for your information. I kind of talk from scratch over there, so you can review it. About sets, about union, intersection, difference. Okay, power sets, remember? Okay, and also cross products, relation, function. Let me just ask you a very simple question. What is the difference between a relation and a function? We'll put it this way. Is a relation always a function?
No.
I heard no. Yes? No? Why no?
In function, you have these one-to-one chains by addition and injection, but in the
Uh-huh.
relation, you don't have that.
Yeah, basically think about, okay, it's a very important distinction here. Relation simply means for every domain value, you may actually map to more than one range values. But in the case of function, every domain value may map to at most one, at most. Okay? But if there's only maybe some domain value does not map to range value, it's called partial function. Okay? That's kind of the stuff that's covered in the review. If you're not comfortable, review it for your learning. Anyway, so let me just go to, okay, so now this is more about how the mathematical concept up to here is related to math models. So in math models, you can basically simulate every set relation operation, for example, and set operations at the runtime. Okay, that's a good thing. So you can write contract. That's very powerful. Okay, I will go over this particular concept with you. But for now, I would like to go over some very quick case study. I want to do both. Okay, so we only got about 10 minutes. Domain, range, inverse, domain. Do you know what a domain restriction is? Have you heard of it? No, haven't? Then you better review it. Okay? How you do domain restriction, how you do domain subtraction, how do you do domain range restriction, how do you do range subtraction. Somehow restriction means I want to somehow filter out the relation by a certain domain. Okay, okay, we'll see example. Okay, don't worry, I'll go over some example with you. No, I cannot completely skip it, right? Even though it's a review. I'll get there, don't worry. But now I want to present to you a very quick case study. So you got time to think about it before Thursday, okay? Also injective, subjective, bijective, right? That's all the concept you learned, the good stuff from 1090. Okay, some diagram here, right? All right, anyway, so this table over here summarizes, for every command that you have in the math model. For example, you can see, let me see the first one. If you see domain restrict, so that one is a command, which means modifies the current, the context objects, okay? Domain restricted is simply just going to return a new mathematical objects, okay? We'll see example just in a moment, okay? I'll go over this later. So now what I want to do now is think about some examples so we can talk about things together. Birthday book. Okay, for those of you who took 2030 with me, you have seen birthday book. But if you haven't, that's okay. It's not required. Okay, let's see what a birthday book is, and then we have some discussion. Okay, and then we'll do the complete design and implementation next time. Okay. A birthday book is simply a collection of entries. Okay, basically every entry is going to be a person's name with their birthday. Okay, easy. No, of course, that's quite obvious. No two persons should have the same birthday, right? Oh, actually, no, sorry. What I meant was a single person should not have more than one birthday. Right? They should be only born a single day, right? That makes sense. Okay, so now, and also, for every birthday, it's going to be a month and a day. Okay, and then now, initially, a birthday book is simply just empty, no entries. Given the birthday, what can we do? Okay. We can ask about how many entries are there, like a count. That one's easy. We can add a new entry into the birthday book. Okay. When we say add a new entry, two cases. It could be that Alan doesn't exist in the birthday book. We want to add Alan to it. Or it could be that somehow we enter the data for Alan wrong. We want to fix it. That could be another scenario. Okay. You can also remove the entry. Now, the last one is the most interesting bit. Okay? Let's say this. Let's say I got a very large birthday book for my friends. Somehow I want to find out all the friends whose birthday is today. How do I find it, right? Well, you pretty much know how to implement that, right? But now, how do we do that and also write some mathematical contracts for that? That's the challenge. Find the birthday of a particular person and also get a reminder list. That's the most interesting part. Given a particular birthday, you want to know all the people who were born on that particular day. Okay? Let's say a little bit about design over here. Okay? How can we make the design happen? Okay? Classes, you're going to think about classes, client supplier, inheritance, and how to use math model so that how many ways can you implement the birthday book? How many possible ways? Well, if you took 2030 with me, a very inefficient way, well, at that time it was not so inefficient, but now since you have taken 2011, one way to do it is by saying I have two arrays, one for names, the other one for birthday, and with the corresponding position, the entry, right? Pretty much like a repository for your lab 2. How do you make a very efficient birthday book? Hash table, good. Anything else? Hash table, given that collision doesn't happen so often, when you try to get access, it can be constant time. I agree. How can I get guaranteed, let's say, login time, when every time I want to search? What kind of tree? AVL? Okay, good. Okay, can I say binary search tree? When it's a binary search tree, it's tricky, right? You got to say it's balanced binary search tree. Binary search tree itself can also take big of n time. Okay, anyways, an aside. But now we want to say, somehow, from the external user's point of view, all they want to understand would be how you actually formulate your birthday book. Now, here's design decision to make. What should the birthday book be from the external user's point of view? Should it be a function or should it be a relation? That's a big design decision to make. I heard function. Anybody think we should be relation? I heard relation. Okay? Let's see this. Remember what I said about relation was, okay, it's a big question here, right? Should it be a relation or should it be a function? If you choose relation over here, oh, sorry, haven't written much yet. If you choose relation over here, so what does that mean? That means you can think about, oh, Get rid of it. Let's say over here, relation means every domain value may map to more than one range values, right? So that means I may have Alan over here, and then in the range part, Alan might be born October 1st and November 5th. Does that make sense? No. So relation is not possible. What do you mean, do it the other way? Oh, no, it wouldn't help. No, I tell you why it wouldn't help. Relation is like a two ways, right? Let's say this. If I actually got relation over here, you're basically talking either is a, okay, but first of all, relation is a generic collection. You gotta give the type of domain, give the type of range, right? Let's say I can either choose to give name, and also I can give birth date. That's one option over here. You can see we got the disadvantage over here, right? Okay. What you're suggesting is swap the type. Okay. Let me. If you say relation over here, you want to say date would be date here, and also you got a name over here. That's what you're suggesting, right? We can still run into the same issue. We can. Because, think about this. Let's say I put October 1st here. I put November 5 over here. Can I still get Alan over here? Yeah, it's still a perfect relation, right? So relation is, so swapping the type of domain value is not the way to go. That's my point. Good try. Well, it simply tells you that in this particular situation, every person should have a unique birthday, right? So function is the way to go. Okay? If I ask you this in the exam, would you know how to justify? Think about it. Okay? Yes. Oh yeah, exactly. Yeah. So yeah, in exam, I can tell you exactly how I might put it in the exam. Okay, in the exam, we'll say, okay, let's talk about this particular birthday book where there should be no duplicates for the names. In that case, I would say for every person in the book, they should map to exactly one birthday, no more than one. In that case, you can judge to see whether you should use relation or function. Yeah, I'll be clear. Yeah. All right, guys, the first decision we have to make. Give me 2 more minutes, and then we can continue next time. Give me 2 more minutes. Basically, for the contracts, you're going to basically write in terms of the function as opposed to relation, okay? And then, what about implementation decision? Well, as we said before, you can either choose array, linked list, which may not be so efficient, that's fine. It's linear time, and also AVL tree, like what you mentioned, log n, hash table with very rare collision should be constant. So now, whatever strategy you choose, like a strategy 1, 2, and 3 for the stat, doesn't matter for the user. All they have to know is you're using a function to write the contracts. That's the key. So next time, on Thursday, when I show you the example, we're going to see that from a design point of view, you only see the contracts being written in terms of the relation. Okay? Let me mention one more thing, and then we can finish for today. Before Thursday, I have only one assigned reading for you. I never did it so far, right? Just one. Okay, only one page. Take a look at this test over here. Get a feel about how you can use the math models. We'll go over anyway, but I will suggest you try to understand what's domain subtraction and using command version and also the immutable query version. Look at that, okay, before Thursday. And then we'll continue with this. Hopefully within 30 minutes we can finish this and then we'll go on to the next topic. Okay, see you on Thursday.